Hello, everyone, and welcome to this 10th episode of my publication at a glance. Today, we have the pleasure to welcome Mathilde Armand, who is currently a PhD student at the University of Poitiers under the supervision of Professor Sébastien Thibaudot. And she will talk today about the elusive glycosylium ion superacids. Mathilde, the floor is yours.
Thank you for this introduction, and thank you for this opportunity to present this work. In our publication, we highlight the ability of the superacidic environment to stabilize depotate glycosyl cations long enough to study and characterize them by NMR. Next, we explore whether glycosylium ions in superacidic environment resemble the strong oxocarbenium ion-like transition state of glycosidase. For that, we use quantum mechanicals method to model both superacidic environment and glycosidase active site. In this project, QMMM calculations were carried out within the research group of the Professor Rovira in Barcelona, and the NMR studies were conducted in a collaboration with the Professor Barbero's group in Bilbao. All of this project was done within the framework of INR funding and the CNRS ERP project. So glycosidase are among the most efficient enzymes in the living organisms, and they catalyze the hydrolysis of sugar, and the dysfunction of this enzyme is the cause of the many human pathologies. And for example, during this reaction, the glycosidic bond is broken by the enzyme. And then the charge reaction intermediate with a strong oxocarbenium ion character is formed. Extremely reactive, this intermediate is then rapidly trapped by the water molecule, leading to the hydrolysis reaction with the inversion of configuration. However, the very short lifetime of the glycosylium ions has always prevented the experimental observation. For example, the lifetime of the glycosylium ions protected by benzene group has been estimated to be less than 1 second in dichloromethanes. And the lifetime of the glycosylium ion and 2-deoxyglycosylium ion has been estimated to be only a few picoseconds in the water. In this publication, we specifically study 3 glycosyl cations. And for example, we study the fluoronosylium ion by the in situ low temperature NMR. We confirm the presence of the fluoronosylium ions by NMR with a strongly D-sheet signals at 8.94 ppm attributed to the anomeric proton of the fluoronosylium ion. Superacidic environment also has a unique ability to fully protonate the cationic spaces, as observed with the 2 signals above 10 ppm. Between 6 and 3 ppm, we also observe the characteristic signals of the fluoronosylium ion. These signals were attributed to the several protons of the cationic spaces, allowing us to study the different coping constants. And in this case, for example, with these 3 coping constants, we hypothesized that fluoronosylium ion prefer to adopt the 3E envelope conformation in our condition. And this result were confirmed by the DFT calculations. We sought to determine whether an analogy exists between the glycosyl cations observed in a superacidic environment and those observed in an environment of glycosidase. To this end, modeling the superacidic environment allows us to study the interaction involved for the 3 glycosyl cations under investigation. And then we model the active site of the several glycosidases of interest, specifically chosen for our studies to compare their properties with those of the glycosyl cations observed in the superacidic environment. Finally, NMR spectra and theoretical calculation revealed a strong structural analogy and similar intermolecular interaction between the different glycosidium ions observed in supracidic environment and the transition state with the pronounced oxocarbenium ion in several glycosidas. This result confirms the potential of the supracid environment to stabilize and characterize key transition spacing and open new perspective, particularly as a tool for designing powerful and selective glycosidase inhibitors. If you would like more details about our work, feel free to check out our publication. Thank you for your attention.
Thank you for sharing your results and this great presentation. If anyone watching this video is interested into participating in this initiative and doing a video for their own research, do not hesitate to contact us via the email, or again, you have more information on the site of the association. See you next time. Bye.